Yo, 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 what's up, everybody? Math by the Moon today here. Going to help my Algebra 1 kids with systems of equations graphing. We unfortunately do not have our TI-84 Plus at home, so we're going to have to see how Desmos is going to be our priority and our method to solving these. So, you ready? Ooh. Gotta start this though, guys. Gotta start this with our song. I definitely have to do it. So I'm just gonna bear with me here. There's something going on in math today. I wanna know what it is. We're finding solutions to systems of lines. We graph two lines in the coordinate plane and find out where they cross. It sure ain't no surprise. Solution is the point. Solution is the point where they cross in the plane. Solution is the point where they cross in the plane. So yeah, you guys remember that? That's that jam right there. The solution is the point where they cross in the plane. So let me get up Desmos here for you. And our first thing to look at here is we have our types of answers that you could get to a system of equations. I'd say the majority of the times you're looking at just a single point, an ordered pair. This blue and green line intersect at the exact location, -2, 1. It's on both lines at the same time. That is the solution. In case number 2, these two lines, they graph parallel and they never crisscross. So one thing you'll notice about parallel lines is their slopes are the same, but they have a different y-intercept. So their rise and run, it's consistently the same in both of these lines, but they just start at a different spot on the y-axis. The third case happens, and they try to sneak these in here. They're the ones where the lines end up being exactly the same. So they could be written in two different forms, like one's written in slope-intercept and the other one's written in standard form. And you're doing the math, and all of a sudden you punch it in, and you're like, oh wait, that's actually the same line. And if it's the exact same line, there's going to have infinite solutions. Whatever the points are that are on one line, those same points are on the other. So we say infinite solutions if they're the same exact line. So let me just pause this for a second, and we're going to pull up the Desmos website. The first example I want to do with you with Desmos, just so you get familiar with it, it's actually the same built-in screen that you have on your Edgenuity. So it's, the calculator options pop up on the side screen, and you can actually select Desmos, the Desmos calculator. You don't have to go to another web browser. So here's the first example. I have 2x plus 1, and let's say it says y equals 2x plus 1. I can type that whole thing in there. And the other one is y equals -2x plus 3. The nice thing about this situation is both lines are already in slope-intercept form. The solution, now, it's going to have some random points on here, but you want to kind of come over here to your line, and you want to click at the intersection point, and it will actually tell you. So it's even easier than your graphing calculator, where you had to go into the menu and hit second calc, trace option 5 for intersection, enter, enter, enter. We don't have to do that with Desmos. It's really nice. So the answer to this is 0.5, 2. So if I were to take 0.5 and stuff it in here, 2 times 0.5 plus 1, that's going to be a 2. -2 times 0.5 plus 3, that's also going to be a 2. So it works in both equations. That's the way a system of equations is meant to be solved. Whatever the point is that works in one equation has to work in the other. So you might even find yourself doing a substitution of the options to see if it works if you choose not to do the graph in Desmos. But the graph in Desmos is super sweet. I wanted to do a couple of special lines like vertical lines and horizontal lines. Y equals x plus 2. And then the other line is x equals -3. So you can see that x equals -3 gives us this vertical line right here. I come over here and I click, and it's -3, 1. -3, 1 is the solution to the system. Can't get any easier than Desmos, guys. So when you're doing this whole section on graphing to find solutions to systems of equations, just open that bad boy up and start typing them in. Even if you had a y line, like a horizontal line, like the x line hits the x, the y line hits the y, y equals 5, and y equals x minus 4. Okay, so this one intersects the y line is y equals 5, and x minus 4 hits at 9, 5. And these actually you can do kind of quick if you wanted to. If y equals 5, you'd put a 5 in right here. You add 4 to both sides, and you get 9 anyway for x. So 9, 5 makes a lot of sense for the solution. Let's take a look at one where the two lines, you may or may not realize they're the same line. So and that's why it's even trickier with Desmos, because you can type these things in our graphing calculator. You have to solve the equations for y before you could put them in. In Desmos, you don't even have to do that. So let's say the equation is 2x minus y equals 6. And again, we would have to convert this. We would have to do minus 2x and divide by -1, and then we would get it into y equals form to put it in our calculator. You don't have to do that with Desmos. It's nice. Y equals 2x minus 6 is my other equation in this system. And you can see that it just kind of blanketed over. If you watch that, if you rewind this for 10 seconds and you watch that line as I hit the -6, it just traced over the same exact spot. So these two lines are identical. So the answer to this would be infinite solutions. And you could actually go right up and down this line and say any point that's on this line is a solution to the system. So yeah, don't feel like you have to manipulate the equations if you're using Desmos. It should just be really nice. And don't forget, the solution is the point where they cross in the plane. Ooh, just had to get that out today. So I hope you enjoy a little bit of Friday fun. If you get to graphing systems of equations, use Desmos. Miss you all.